The next piece of 303 basic acceptance test is called a sand equivalency test, or SE. Again, the calculation for the SE is super easy. The procedure itself, there's a little bit more to it. But basically what I'm going to do is I'm going to take out the fines of the material. That is the material that is -4 on that sieve. So I'm just going to shake out that -4 material. I'm going to condition it to about optimal moisture content. And I will show you guys all how to do that. And what's going to happen is I'm going to put it into a volume or a graduated cylinder. I'm going to add a solution that's basically going to break up all the clay particles. We're going to go all the way through to basically shake it up, make sure it's mixed really well. There's a whole procedure to it that you'll see here in a second. And basically what I'm going to do is I'm going to measure where the clay settles out at. So what's going to happen, this is my cylinder. This is my cylinder. It's going to come up to a certain amount. And my sand, you're going to get the bottom, because it's the heavier stuff. I'm going to have clay. And then it's just going to be my solution up to the top. So what I'm going to do is I'm going to read my clay line. Let's say the clay line was at, let's call it 4.6 or something. Okay? My clay is somewhere. What I'm going to do is I'm going to take a weight, I'm going to put it in there just to make sure the sand is nice and compressed. This weight is going to be on a rod that is calibrated to exactly 10 milliliters. So what's really going to happen is I'm going to put the weight in, it's going to compress the sand down, and I'll get a reading up here of 13.2. I'm going to subtract the 10 off of it because that's my adjustment factor, which really is 3.2. And then for your SE, all it is your sand line divided by your clay line. Now for most of these 303s, your spec is I believe it's a max 30, or a 30 minimum, excuse me. So that's your spec, it's going to be a certain percentage, and that is it for the SE. So the fracture face is the last portion of this test, and again, super easy. All I'm really looking for is I believe it's 50% of the rock more fractured. And again, this is going to be in the AASHTO that you'll look at. I don't think I have the STM, so I'll only post the AASHTOs, but do I visually think that a certain percentage of the rock is broken? If it is broken, it's going to one pile, and if it's not broken, it's going to go into another. So this is the +4 material only, so it's going to be the coarse stuff. And what I'm going to do is I'm going to make 3 piles. I'll have my fractured, my questionable, and my non-fractured. So this whole mass, I believe it's 1,000 grams I need in total. So out of the fractured, if I have 700 grams, my questionable I have 40 grams, and my non-fractured I have 310 grams. Now the way that this calculation is going to work, and again, this is all on the 901 form that I'm looking at right now. It's going to be my fractured plus the questionable divided by 2 divided by non-fractured. Divided by the fractured plus the questionable plus the not times 100%. So all I'm doing is I'm taking my questionable, I'm cutting it in half, and I'm adding it to this section. Now, if my questionable adds up to more than 15% of my total sample, I have to reevaluate and go back and do it again. Typically, when I run these tests, I try to have no questionable, but for the sake of you guys in the lab, might as well make it slightly more complicated and give you guys some small amount, because why not? And that is in the procedures. If you go and actually get certified through WAC to do these tests, that's one question they ask is, what if you have more than 15%? So might as well include it, because this is trying to make it real life as opposed to laboratory school stuff. But so this is the equation. You gotta have a maximum of 70% normally to qualify or to pass this 303 basic acceptance. And that's it, we're done. Okay, so I don't have a super large sample, so I'm just gonna combine 2 of them that are from the same project that are supposed to be the same material, so it'll be good enough for what it is that we're doing. Now, I'm gonna take my 303 base, I'm gonna put it into my sample splitter. This is a official approved IGB method for splitting samples. I'm going to put them both in there just to make sure I have enough. In the procedure, all you need to do is say, I split the sample, split sample down to size. Now, this is a 3/4 base, so the minimum sample size is 5,000 grams. So, I'm going to evenly spread it, and I'm going to open this up, and those are clean, there's nothing in them. I'm going to open it up, till it's freely flowing. Okay, close that. Now, that's still more than 5,000 grams, so I'm going to do it again. All this is doing is halving my material. Bring it there, okay? Open it up. Pt2, 51.5. So this is going to be my whole moisture content. So what I'm going to do is I'm going to take this whole guy. Possibly. So I tore out my pan, my tear. Dump this whole guy in there. Make sure my masses are still the same. 51. I'll change that. 5.2, 51.8. 5.2. We go, put this on the burner. So I'm gonna cook this guy. If you actually read the specs, it's gonna say dry to constant mass. Constant mass is when it is in a little formula that we can do. I'm not gonna do it. If you guys want to include it, you can. If not, I won't dock you. Constant mass, all that means is that for every time I put it back on the stove, cook it out, the mass isn't going to change by more than 0.1%. The mass continues to change by more than 0.1% between intervals, and I didn't get all the moisture out of it. I'm just going to cook it until I know I got all the moisture out of it. There's not a whole lot of moisture in this in the first place. Awesome. Okay, so now what I'm going to do is I'm going to take my number 4 sieve, which is about like this. Over a bucket, and I'm going to split out my 2 samples for my SE and for my fraction base. You take my sample, put them on there. And then out. do, get close to 1,000 grams, or 1,000 grams actually, exactly. Minimum. There's a lot in there. I'm going to pull some out. Need it. It is slightly, it's not as important to have a really good split on this one. But so that's a little more than 1,000 grams at 1346. So I'm going to set this aside. Run my fracture face on. Again, just to remind you guys, grabbing samples like like I did there and like I did earlier, that is not an approved thing. It's not something I normally do, but seeing as that this isn't an important lab, or that these aren't tests that I'm submitting to the state, for example, I'm not super worried about it. It's totally going to you. So I'm going to take my fines. We come over here to the quartering clock. This is for the SE. And a standard equivalency test. What I'm going to do is I'm going to dump them all out. Now I need to get this to optimum moisture content. Optimum moisture content, similar to how I did in the first lab, when I got it to surface saturated dry by making a hand cast, and it's falling apart right there. Optimum moisture content is a similar method, except instead of it falling apart basically immediately, I want it to hold its shape until I shake it and then it falls. So I'm just going to add this moisture and I'm going to keep mixing it up. Now this is an approved mixing method and this is an approved way to do this. There's a very similar method for asphalt as well, but this is soils, not asphalt, so that's all we really need to talk about. Trying to get evenly opened up and mixed. Now, according to the procedure, I need to do all 4 quarters at least twice for the final mixing. I'm just going to keep doing it. This is a good mixing method. So that's a good hand cast. I'm going to shake it and it falls apart. Good hand cast. Shake it and falls apart. Okay, so now I'm going to do my final mix. So 1 and 2. Now I'm going to put it all in the center. I'm going to wrap it up. So it's like that. It needs to sit for 20 minutes. Again, that is the spec. We'll start that timer, and we're going on now for 20 minutes. Now, before I keep on forgetting, because I'm fixing this guy, it does need to be consistently mixed. I can see in there where the moisture kind of is. And then, according to any specification, you'll see about using a, I believe it's called an unregulated heat source, such as a hot plate or a fire propane burner like we have here. It is supposed to be continuous mixing. So brush all my fines back into there so I don't have any errors in that measurement. And it's sitting just like that. We're going to keep drying and we'll go do our fracture face right now.